Today's topic is Simplified Data Encryption Standard. Before entering into the topic SDES, first we are going to see some introduction about the cryptographic algorithm. So cryptographic algorithm is nothing but what we are going to do in cryptographic algorithm. Many cryptographic algorithms is there. In cryptographic algorithm, we are going to convert the plain text into ciphertext. Two technical terms we are going to use. One is plain text and other one is ciphertext. Plain text is nothing but the original text and ciphertext is nothing but the ununderstandable format. It is going to be there in ununderstandable format. So two terms, there is plain text and ciphertext, and we are going to classify the cryptographic algorithm into two kinds. The first one is symmetric encryption algorithm and the second one is asymmetric encryption algorithm. Symmetric encryption algorithm is nothing but in both the encryption side and the decryption side we are going to use the same key. That is symmetric encryption algorithm. In asymmetric encryption algorithm we are going to use two different keys in both the encryption side as well as the decryption side. That is asymmetric encryption algorithm. Today we are going to see a simple symmetric encryption algorithm SDES. This is nothing but a simplified version of DES. In DES, we are going to convert the 64-bit plain text into 64-bit cipher text using Feastel cipher structure with 16 rounds. But in simplified DES, this is going to be a simplified version of a DES. So in simplified DES, we are going to use the Feastel cipher structure with 2 rounds, and we are going to convert 8-bit plain text into 8-bit ciphertext. So the professor Edward Schaffer of Santa Clara University has introduced our simplified DES algorithm. And in simplified DES algorithm, we are going to convert 8-bit block of plain text into 8-bit block of ciphertext using 10-bit key. So here first we have to convert totally 2 rounds of Feastel structure will be there in SDES. So we have to convert this 10-bit key into two 8-bit keys that each key will be used in each rounds. So in SDES encryption, totally 5 functions will be there. The first function of SDES is going to be an initial permutation. So initial permutation is nothing but just we are going to rearrange the position of the bits. That is going to be the initial permutation. And second one is complex function labeled FK. So here the complex function, here we are going to maintain the round function. So round function, for a particular round function in SDES, we are going to follow the Feastel cipher structure. And the third one is after performing initial permutation and the complex label the function, here we are going to switch the data. First we are going to divide the data into two halves and we are going to switch those two halves. That is a third function. And the fourth function for second round, we are going to repeat the same complex function fk for the second time. So that will be considered as a second round of SDES. And the last function is going to be the inverse of the initial permutation. So totally 5 functions will be there in SDES. For SDES encryption or the SDES decryption, totally 5 functions will be there. In SDES encryption, it is going to be first function is going to be initial permutation, second function is a first round, that is complex function, third one is switch function, and fourth one is the same complex function fk for second round, and the fifth function is inverse of initial permutation. So now, before entering into the SDES encryption, first here the given input is going to be a plain text as well as the 10-bit key. First we have to convert the 10-bit key into two 8-bit keys. The two 8-bit keys we are going to use for each round of simplified DES algorithm. So here now we are going to see how we are going to convert the 10-bit key into two 8-bit keys. First we are going to see the architecture diagram for converting the 10-bit key into two 8-bit keys. So this is the architecture. This is the architecture diagram of SDES key generation. The input is going to be the 10-bit key. First, we are going to perform permutation 10. So permutation 10, they will gives you the output of 10 bits. Then we are going to divide into two halves. The left side of first 5 bit and the right hand side of next 5 bit. So first 5 bit, first we are going to do the left shift for 1 bit, and in the second 5 bit, then for that also we are going to do the left shift of 1 bit. That we are going to join it. After joining that both the output of LS1, then we are going to perform P8. So out of 10 bit, we are going to select any 8 bit. That will gives you the key K1. So now we have generated the first key of SDS as key K1. Then the next step is going to be the next for LS2, the input is going to be the output of LS1. First, we have to take the output of LS1, the 10 bit of the 10 bit output of LS1 step. We are going to take as an input for LS2. So LS2 is nothing but left shift 2 bits. So left shift 2 bits for the first half as well as the second half. The output of LS2 is also is going to be the 10 bit. That 10 bit we are going to put that 10 bit we are going to perform the permutation 8 function. So out of 10 bit we are going to select the 8 bits. So that will gives you the second key of simplified DES algorithm. So this key K1 we are going to use in the first round of SDS encryption, and the second key K2 we are going to use in the second round of encryption, SDS encryption algorithm. So now we are going to see the encryption scheme. So the encryption scheme is nothing but what is the encryption architecture diagram of simplified DES. So in simplified DES, we are going to convert the 8-bit plain text into 8-bit ciphertext with the 2 round and with the help of 2 keys, that is key K1 and key K2. So here input is going to be the 8-bit plain text. First we are going to perform initial permutation. Then after performing initial permutation, we are going to divide into 2 halves. For the first one is as a left half. We are going to consider the first half as a left half and the second half as an right half. So here we are going to perform a complex function. We know already in encryption scheme we are going to use 5 function. First function is in the initial permutation. Then second function is going to be the complex function. Complex function is nothing but the round function. So round function of SDS encryption algorithm is Feistel cipher structure. So Feistel cipher structure, the standard formula for Feistel cipher structure is L exclusive OR of f of r comma sk comma r. So that is going to be the standard formula for Feistel cipher structure. So here, see here L exclusive OR. Here we have taken the left part and we are performing exclusive OR here. The next one is f of r comma sk. F of r comma sk is nothing but we are going to perform some function with the right hand side bit, that is r comma sk. Sk is with the help of sub key. So here we are having 2 sub keys, that is key k1 and key k2. So here L exclusive OR of f of r comma sk. After completing this part and after completing this XR, it will gives you the output of L exclusive OR of f of r comma sk. Then comma r. That comma r is going to be this part. So here at this part we are getting the output of L exclusive OR f of r comma sk and comma r. So this is a standard formula of Feistel cipher structure. Based upon the number of bits we are going to change. But the standard structure for Feistel cipher structure is this one, L exclusive OR of f of r comma sk comma r. In SDS we have used 8 bit, but in DES we are going to use 64 bit. Only the number of bits is going to change. Remaining thing, the structure is going to be the same. So here we got the second function of simplified DES encryption output, that is complex function fk, and the third function is switch function. So here we are going to switch the right hand side output into the left hand side for the second round, and the leftmost part output we are going to give as an input for the right hand side for the second round, and the same complex function we are going to do here. So complex function is nothing but the round function. So here in simplified DES encryption algorithm we are going to perform the second round function. I already said totally in SDS we are going to do 2 round functions. So this is the first round function and this is the second round function, but all the structure inside the round function is going to be the same. As here it is using Feistel cipher structure, and I already explained L exclusive OR of f of r comma sk comma r. So now the fourth complex function, that is fk for second round, is over. So here we are getting the output as an 8-bit. Then fifth complex function, the fifth function of SDS encryption is going to be IP inverse. IP inverse is nothing but inverse of initial permutation. So the inverse of initial permutation is not, here this how it is going to give the output, that we will see in the numerical problem after few slides. So now I have explained the whole encryption part of SDS. So until now we have seen the structure of the key generation structure as well as the SDS encryption structure. So now we will see the numerical problem of key generation with the help of the architecture diagram of key generation, and then we will see the numerical problem of encryption with the help of the architecture diagram of SDS encryption. So now we are going to see the SDS key generation. So in SDS, we already know 10-bit key will be given. That 10-bit key we are going to convert into two 8-bit keys. So here the given part is going to be the 10-bit key, as well as in the structure we are going to perform permutation 10 and the permutation 8. The permutation 10 value is also given in the is given in the problem, and the permutation 8 value is also given in the problem. Suppose if it is not given in the problem, you can randomly choose the value of permutation 8 and the value of permutation 8 and the random value of permutation 10. So now let us solve the problem. Now let us convert the 10-bit key into two 8-bit keys for simplified DES algorithm. So here, what is the first step? First step is permutation 8 in simplified DES key generation. So the input for the permutation 10 is 10-bit key. So here we are having 10-bit key as 101 and 5 zeros 10. So this is going to be the input for permutation 10. So here the value for permutation 10 value is also given in the problem itself. So for what we are going to do here is the first input, the first bit is going to be the third bit of 10-bit key. So what is third bit of 10-bit key? 1. The next one is fifth, 5. So what is the fifth bit of 10-bit key? 0. The next one is 2. Then what is second bit of 10-bit key? 0. The next one is 7. What is seventh bit of 10-bit key? 0. So like that we are going to do the permutation 10. So after doing the permutation for this 10 for this 10-bit key, we are getting the output like this. This is going to be the first step for the SDS key generation. And the second step, what we are going to do, so by taking the output from the permutation 10, we are going to divide into two halves. That is first half and the second half. What is the first half? First half is this. The first half is till this we are going to consider it as an first half, that is 140. So now what we are going to do, we are going to do the left shift 1. If we are doing the left shift 1, what it will happen, it is going to shift the shift all the bits, it is going to shift one bit left. So what it will happen, this one will occupy the fifth, this one will go and occupy the fifth place. So this is going to be the output of left shift 1, and then the next half part. What is the next half part? 0, 1, 1, 0. Then again we are going to do the left shift 1 for this 5 bit. Then this 0 will come here. Then what is the output of this? 1, 1, 0. So now we are getting the output of this LS1 part also and this LS1 part also, and this 2 is going to be, this 2 are the output of these two LS1. So what is the third step? Third step is we are going to perform the permutation 8. So here totally we are having 10 bits, and what is the permutation 8 value? So here permutation 8 value is given as 63748510. So here among this 10 bit, what is the first bit value according to the permutation 8? 6. So here we are going to select the sixth bit. So sixth bit is 1. The next one is 3. So here we are going to select the third bit. So third bit is 0. Then 7. Seventh bit is 1. Then 4. Fourth bit is 0. Then 8. Eighth bit is 0. So like that we are going to do the permutation 8. So from these 10 bit we are going to select 8 bit here. So now we are getting the output for key K1. So now we have derived the first subkey for SDS encryption algorithm, that is key K1. Then the fourth step, we are moving to the fourth step. What is the fourth step? Fourth step is LS2. The input for the LS2 is the output of LS1. So we know the output of LS1. That these two are the output of LS1 on the right hand side. Both the left hand side and the right hand side. So here we are going to do left shift for 2 bits. 2 bits means this 20 will occupy the last 2 bits. So 00100. And here in right hand side, this 2 bit will occupy the last 2, is moving to the last 2 bits. So here 00011. This is going to be the output of LS2 part. So the output of 4, that fourth step is going to be these two, this 10 bits. So now the last step in key generation is going to be permutation 8. So permutation 8, it is the permutation 8 value is already given in the problem. From these, from the output of LS2, we are going to extract the 8 bit using permutation 8 position. So here we will be getting 0, 1, some this value. See here, what is the permutation 8 value? 6th bit. What is the 6th bit here? 0. Then third. See here, what is the third bit value? 1. Then 7. See the what is the 7th bit value? 0. So like that, we are going to extract the 8-bit value from the from the 10-bit value of LS2. So now after performing the permutation 8, this will gives you the second subkey of SDS encryption key K2.